Start with a more dramatic introduction. Pose thought-provoking questions that get viewers curious about the solar system's mysteries. For example, ask how the Kuiper Belt could have changed our understanding of life in the universe. Provide more history behind the Kuiper Belt's discovery and how early astronomers theorized its existence. Include more details about how its role in our solar system evolved. Go deeper into the science of what the Kuiper Belt is, explaining its composition, its role in shaping our solar system, and the significance of its objects. You could include comparisons with other regions like the asteroid belt and scattered disk. Expand on the exploration missions, for example, New Horizons, with more details about their findings. Include descriptions of specific objects found in the region and their characteristics, for example, Ultima Thule. Discuss the challenges faced by researchers in studying such distant regions. Dive deeper into how the Kuiper Belt may provide insight into the early solar system. Introduce a more detailed explanation of how scientists use this region as a time capsule for studying primordial materials. Include more scientific theories and hypotheses related to the formation of life and the origins of organic compounds in the Kuiper Belt. You can explore ideas like panspermia, the theory that life could have originated elsewhere and been spread through space, and how this could relate to other icy moons or exoplanets. Elaborate on the current search for new planets or objects within the Kuiper Belt. Mention the theory of Planet 9 and its potential significance in the context of the belt. Expand the conversation on the possibility of life beyond Earth. Discuss in greater depth the possibility of life on icy moons or other planets based on the findings from the Kuiper Belt and other regions of our solar system. Wrap up the script with questions or a call to action, inviting viewers to consider how these findings change our view of the solar system. Leave them with thought-provoking ideas about the mystery of the outer reaches of our system and life beyond. Have you ever wondered what secrets lie at the very edge of our solar system? The vast, icy expanse known as the Kuiper Belt has been a topic of intrigue for scientists and space enthusiasts alike. Located far beyond the orbit of Neptune, this mysterious zone has been largely unexplored until recently. But now, with groundbreaking discoveries from NASA and new research, we are starting to unravel the dark, frozen history that lies within. Could these findings rewrite everything we thought we knew about our solar system? What if there was something out there, something terrifyingly important, that we've been overlooking for decades? In this video, we'll take you on a journey through the Kuiper Belt, exploring its hidden secrets, bizarre objects, and mind-bending implications for the history of our solar system. Hold on to your seats, because what we're about to reveal might just change everything. The Kuiper Belt is an icy region that lies at the outermost edge of our solar system, beginning at about 4.5 billion kilometers from the Sun and extending all the way to 7.5 billion kilometers. This region, which is far colder and darker than anything we experience here on Earth, holds a wealth of astronomical treasures that have largely been overlooked, until now. Despite its vast size, about 20 times wider than the main asteroid belt, the Kuiper Belt is still a largely unexplored frontier. Only a small fraction of this frozen zone has been studied, and every time we venture into it, scientists uncover something new, something strange. These objects are not just random ice blocks or rocks, they are relics from the early solar system, time capsules that offer a glimpse into the birth of our Sun and the planets we know today. Why is the Kuiper Belt so important? To understand its significance, we need to take a step back in time, billions of years, to the very birth of the solar system. Our Sun, like other stars, formed from a giant cloud of gas and dust, which slowly collapsed under its own gravity. As this cloud collapsed, it began to spin, forming a protoplanetary disk. In this disk, smaller particles clumped together to form larger objects, and eventually, planets. But not all of the material in the solar nebula was able to condense into planets. Some of it remained in the far reaches of the system, beyond the orbit of Neptune, and formed the Kuiper Belt. Here, objects that were once part of the primordial solar nebula remain frozen in time, untouched by the processes that shaped the inner planets. These objects are essentially fossils from the early solar system, and they hold critical clues about how our entire system came to be. The exploration of the Kuiper Belt began in earnest in the 1990s, but it was only with the advent of powerful space probes that we began to make significant progress. Pioneer 10 made a brief flyby of the outer solar system in the early 1980s but did not encounter any specific Kuiper Belt objects. It wasn't until 2015, with NASA's New Horizons mission, that we began to truly explore the outer edges of the solar system. New Horizons made history by sending back the first detailed images of Pluto, and it didn't stop there. After completing its flyby of Pluto, New Horizons continued its journey deeper into the Kuiper Belt, eventually encountering a bizarre and mysterious object known as Ultima Thule, or Arakoth. This object is one of the strangest things ever found in our solar system. It's misshapen, unlike anything scientists expected, and it contradicts several fundamental principles of physics. But what's even more intriguing is what it represents, a direct window into the past, frozen in time. What makes the Kuiper Belt so fascinating is its pristine nature. Unlike the planets, which have been subject to constant processes of geological change and atmospheric evolution, the objects in the Kuiper Belt have remained mostly untouched for billions of years. They are, in essence, fossils of the solar system's earliest days. By studying these objects, we can learn more about the conditions that existed in the solar nebula and gain insight into how planets like Earth were formed. Some of the objects in the Kuiper Belt are even thought to contain complex organic compounds, the building blocks of life. This opens up the exciting possibility that life could have originated in the outer reaches of the solar system, or that life could have existed on other planets or moons in the past. Could the organic molecules found in Kuiper Belt objects have been carried to Earth by comets, seeding our planet with the raw materials necessary for life? But the mysteries of the Kuiper Belt don't end with these objects. Some astronomers have hypothesized the existence of a ninth planet, located far beyond Neptune, in a region of space we haven't been able to directly observe. This hypothetical planet 9 could be larger than Earth, and its gravitational pull may explain certain anomalies in the orbits of smaller objects in the Kuiper Belt. So far, Planet 9 has not been confirmed, but its potential significance cannot be ignored. If it exists, this distant world could completely change our understanding of the solar system's structure. It could also offer a more complete picture of the forces that have shaped our outer solar system. Beyond the Kuiper Belt lies the scattered disk, a mysterious and little-known region of space that is even farther from the Sun. Objects in the scattered disk have highly eccentric orbits and are thought to have been scattered by the gravitational influence of Neptune. Some of these objects, like the famous comet Hale-Bopp, occasionally venture into the inner solar system, giving us fleeting glimpses into this distant region. Scientists are just beginning to explore the scattered disk, and there's still much we don't know about this far-off zone. But by studying its objects, astronomers hope to uncover more clues about the dynamics of the solar system, its formation, and the role that gravitational interactions between planets have played in shaping the orbits of these distant objects. One of the most exciting aspects of studying the Kuiper Belt and beyond is the potential to discover evidence of life, or at least, the building blocks of life, on other planets or moons. We know that organic molecules can be found in comets and icy bodies, and recent research suggests that some of the icy moons in our solar system, such as Europa and Enceladus, may harbor liquid oceans beneath their frozen surfaces. Could these moons have supported life in the past, or could they even be home to microbial life today? As we continue to explore the farthest reaches of our solar system, one thing is clear: the Kuiper Belt is not just a region of frozen ice and rock. It is a treasure trove of information, a relic from the ancient past that holds the keys to understanding the origins of our solar system, and perhaps even the origins of life itself. So, the next time you gaze up at the night sky, remember that the answers to some of the universe's most profound questions may be lying just beyond our reach, waiting to be discovered in the icy depths of the Kuiper Belt. What will